Okay, a standard deck of playing cards has 52 cards with the following characteristics. Let's actually look at this in case you haven't spent a lot of time with playing cards. There are 4 suits represented by the different symbols in the middle. So there's the clubs, spades, hearts, and diamonds. 2 of the suits are black, the clubs and spades. 2 of the suits are red, the hearts and diamonds. There are 13 cards in each suit, starting with an ace, which is usually considered like a 1, then 2 up to 10, and then jack, the queen, and the king. Sometimes the ace is considered to be the highest card, even higher than the king. Sometimes it can be either a 1 or the highest card, whichever you want it to be. But for most of these questions, we're going to count it like a 1. The 3 cards that have people on them in each suit, the jack, queen, and king, are called face cards. And so each suit has 3 face cards and 10 numbered cards. So 13 per suit times 4 gives you a grand total of 52 cards. We'll revisit that if we have to, but that should be enough to get us going. So 2 suits are black, 2 suits are red, face cards are jack, queens, and kings. Okay, I think we got all that. So in a game of poker, you have the entire 52 card deck, and they give you 5 cards out of it. How many different ways can that happen? If I've got all 52 cards and I'm going to give you 5 of them, how many different ways could I do it? Well, there are 52 cards. You're getting 5, and the order they're given to you does not matter in poker. You can rearrange them in your hand any way you like. Hold them in whatever order you want. So 52C5 would be the answer. And if we work out that number, it's a ton. The possibility space in poker is very big. 52 combination, 5. There are 2,598,960 hands you can be dealt in poker. Now, out of those hands, now we start doing groupings of cards. How many of those hands will be all diamonds? Don't think of this as chances. Think of this as, if I've got all 52 cards in my hand and I've decided I'm going to give you all diamonds, how many ways could I do it? Well, there's only 13 diamonds to work with. And so if I'm going to give you 5 of them, I can do that 13C5 different ways. 13, combination 5. There are 1,287 all diamond hands I could give you. 4 black cards and 1 red card. Again, if I'm doing this deliberately, there are 26 cards which are black, 13 spades and 13 clubs. I've decided to give you 4 of those. And at the same time, I said and, so I wrote it times, there are 26 red cards, and I've decided to give you 1 of those. So 26C4. What did I do there? 26 combination 4 is 14,950 times, what's 26C1? If there's 26 cards, how many ways can you deal 1 of them? Amazingly enough, 26 different ways. Don't do a C1 on the calculator, it's a waste of your time. 26 cards and you can only hand 1 out, there's 26 ways you can do it. 14,950 times 26, 388,700. There we are. 3 kings and 2 queens. Well, there are 4 kings, hearts, spades, clubs, and diamonds, and I'm going to give you 3 of those. In other words, if I've decided to hand you this, I can throw away everything from aces up to jacks. I don't have those as options. I end up just having 8 cards in my hand and going, okay, I've got the 4 kings and the 4 queens, which ones am I going to give you? From the 4 kings, you get 3, and from the 4 queens, you get 2. 4 combination Combination 3. That's interesting too. 4C3, when you're giving out three from a set of 4, what you're really doing is picking which one of these 4 kings am I not going to give out. And of course there's 4 ways to do that. Handing out one thing and handing out all but one of the things, actually you have the same number of choices. And 4C2 is not so obvious. 6. And 4 times 6 means there's 24 hands you could get that contain 3 kings and 2 queens. 3 kings, and that's it. Well, there's supposed to be 5 cards in a poker hand, so what this really means is 3 kings and 2 non-kings. I can't give out any more kings because I said there are supposed to be 3, but I have to select from all the cards that aren't kings 2 of those. So from the 4 kings, you get 3 of them. And then there are 52 cards in the deck. 4 of them are kings, so that means there are 48 cards that are aces and 2s and 8s and 10s and jacks and queens that aren't kings. From those, you're going to get 2. So you have your correct total of 5 cards. So 4C3 we already have, it's 4. 48C2 is going to be a big one. Combination 2. 1,128 times 4. 4,512. 4 aces. Again, this isn't enough cards, so it's what they really mean is 4 aces and 1 non-ace. From the 4 aces, we're going to select all 4 of them. And from the 48 cards that aren't aces, we're going to select 1. Well, these are actually pretty fast. 4C4, there's only one way to do that. If you've got all 4 aces and you have to give me all 4 of them, then you don't have any choice at all. There's only one way you can do it. And if you have, remember the C1 thing, if you have 48 cards and you only allowed to give me one of them, there's 48 ways you can do that. So there are 48 ways to get 4 aces. You could get 48 aces and the 2 of diamonds, 48 aces and the 3 of diamonds, 48 aces and the 4 of diamonds, and so on. Each of these 48 cards gives you another way to get 4 aces. And finally, 5 cards of the same suit, known as a flush. We actually already solved part of this. We worked out all diamonds as our very first question, so this is what's called a diamond flush. There's 1,287 ways to get a diamond flush. And there's also 1,287 ways to get a club flush, and 1,287 ways to get a heart flush, and 1,287 ways to get a spade flush. Add all those up, because they aren't happening at the same time. It's alternatives. It's one of these or the other. And you should find there are 5,148 ways to get a flush. And remember, a flush came from saying, okay, I'm just using one suit for all of my cards, and from those I'm going to get 5 of them. So each of these numbers is 13C5, and then you just multiply that by 4 because there are 4 ways you can get a flush, 1 with each suit.